group. Everybody got on yesterday that was meant to, so that's always a good thing, especially for a manager like myself. You know, you don't want heartache at the beginning. Okay, Kelly is going to be giving his talk on the countdown to totality in a moment. But before he begins, I'd like to invite Celebrity's own astronomer, Professor David Hughes, to join Kelly and I on the stage. Hello, Professor. Two English people together. Yeah! Okay. Right, well, I'm actually going to now hand over to David, just to say a few words.
Just a few words from me. What is important is that tomorrow you really enjoy yourself. You've made a huge effort to come here, and I feel very humble having only seen 4 eclipses, and whoever I talk to from Travel Quest seem to have seen so many more, but they're never to be forgotten. And what always does worry me, and I said this in my little chat, that as soon as you've seen a few, you're not satisfied. You just want to keep going. But why not? You meet interesting people, you go to lovely places, and it's a marvellous experience. Thank you.
Thank you, David. Okay, Kelly, come on up. And as I said, or if you were reading the plaque this morning, the flip chart down in deck 3, there is also a surprise for you right now. And Kelly. Maybe we should turn it on and just take a vote.
This is great. Thank you all for being here. Thank you all for making the effort. And without further ado, I would like to let you hear what's happening on board the ship from the proverbial horse's mouth, the master of the ship, Captain Taramas, and our navigation officer, Justin Palermo. Please.
Thank you, Captain. I hand over to you.
Good afternoon. What did I say? Well, yes, Deborah is right. We saw each other this afternoon actually, at around 12 o'clock on the bridge, and we went over the plan of how we are going to do things tomorrow and what would be the best to do. So what we are planning right now is what I say as well at 10 o'clock in the morning announcement. I'm looking at 7 o'clock to arrive to the center line of the path, and there to slow down and to position the ship to the best, most comfortable ride to the waves and to the winds. So when the phenomenon starts to occur, everybody to be ready and to maximize the experience. For me, it is an experience. It's my first time that I will see an eclipse. So it's not something that I want to miss. I'm going to be there on time, I'm telling you. And let's hope, and it looks so, that tomorrow will be a nice day. Yes, it will be a bit of windy, around 25 knots. We will have around 2 meters swells. But as I said, the ship will be positioned such a way, and the speed will be adjusted to the most comfortable and most no less course and speed, of course. If I may say that, remember, we are not on land. Okay? I cannot promise you that she will not move at all. That's something that I cannot promise. But what I can promise is that we will try our best, and I do believe that I can make that happen. As much less motion as possible. Now, as of the cloudness, well, we must ask somebody else then. I don't think that we have this answer right now, and as I said earlier, it looks good. We are going south, which means the atmosphere is getting cooler, so I don't think that will be that much moist on the air to create a lot of clouds. Judging from this morning, it was quite nice day. I mean, there were not a lot of clouds. Yeah, we may saw some rain at around 8:30, 9 o'clock passing our bow, but other than that, it was relatively clear skies. So let's hope for the same tomorrow. But I do think that you have some sources too. Yeah?
I'll be telling you in due course.
Okay. So, here with me together today, as Deborah said, and Kate as well, we have our navigating officer, the first officer of the ship, Justin. And if you do have something else to say, please.
No, I really don't have that much to say, except thanks to these two. The ship, we've been able to work together pretty closely since the start of this cruise to replan and replan how the ship is going to go. And the information that they provided to us was pretty extraordinary and pretty helpful to me, because it gave me real positions that I could base things off of instead of Google other websites. So it was pretty nice to be able to find out exactly what was going to happen. I've also never seen an eclipse. I really got no idea what I was looking for when I was supposed to plan this. So when they came and they were able to give me all sorts of information and explain exactly what was going to happen and what we were shooting for, I think we're right on the money now. I mean, we're going to get there tomorrow. We're going to get there tomorrow. It's going to be hopefully a beautiful day. That's all I can hope for.
Before we let them go, everyone, please, I cannot begin to tell you how wonderful the cooperation has been with the bridge, with the captain and his staff, the whole staff of the entire ship, not just on the bridge there. And we look forward to making you official members of the Gotta Go for the Eclipse Society. Please give them another hand.
One more thing before we get off the stage and let you do your things. It is that we are close monitoring the weather, and if there is any changes or we need to alter course to get better position, we will do so. And of course, we will inform you, and you will have to make some last-minute calculations. But
I have a coin.
Okay. So I just want to let you know that every 6 hours we will monitor the weather, and whatever comes up we will discuss again. Okay? Well, thank you very much, and let's hope tomorrow 7 o'clock as planned everything.
Okay, well there it is, from the horse's mouth.
It's an American expression.
Okay, enough from me. Over to you, Kelly.
All right, fine. Here we go. Now, technology is great when it works. All right, well, thank you all very much again for coming here. This presentation is being, many of you have come up to me and asked, okay, we know you're going to tell us, what about everyone else on the ship? I'm happy to tell you that this is being recorded to play over the ship's television broadcast system, so everyone will have a chance. I will say at this point, for those of you here and who might be watching, if I'm putting you to sleep, before you do so, I want to remind you that you've all been given Eclipse viewing glasses in your rooms, along with a 2-page front and back sheet. The front half of the picture shows you how to wear and use these things safely so that we don't have a lot of issues with temporary or permanent blindness, which can easily happen during the eclipse if you're not careful. And then on the back are some basic guides for photography during the eclipse. And with that, let's proceed. So, oh, good, okay. You know, eclipses at their heart are very basic things. Something gets in the way of something else, and changes occur. In our particular case, we are going to be, oh, I don't like the way this is going at all. In our particular case, we're going to be standing in the moon's shadow. And so let's talk about why eclipses occur. For a total solar eclipse to happen, there have to be two or three things that happen simultaneously. You know, the moon's orbit, shown here in green, is not in the same plane as the Earth's orbit, which is the orange line. If that were the case, if they were really the same, then we would have eclipses of the sun and moon every month as the moon goes around the Earth. But that's not the case. There is an intersection point where the moon is crossing in its orbit through the plane of the Earth's orbit. That's first criterion that needs to be met. The second thing is that the moon has to be relatively close to the Earth in its orbit. The moon's orbit is not perfectly circular, so we need it to be close at what is called perigee. And it helps if the Earth is actually at a farther point away from the sun. A great factoid that you can impress your friends with is that the Earth is actually closest to the sun in its orbit, not in June, which is summer for the northern hemisphere, but in January, which I guess is summer for the southern hemisphere, so maybe there's something to that. And so we're in this situation where all three of these things are going to happen. The moon is at new, right in front of the Earth, between the Earth and the sun. The moon is sufficiently close to us, and its cone, its shadow, called the umbra, is going to be on the Earth. You notice that these 2 points are on opposite sides of the Earth's orbit, and what that means is that eclipses right now can not happen just any old time. They have to occur about 6 months apart. So some of you might remember that in May there was an eclipse of the sun visible from a lot of the United States. And so May, June, July, August, September, October, November. And so here we are in November, and things have come around, aligned again, and away we go. Just as quick to tell you that we don't always get, when this alignment happens, we don't always get a total eclipse. When the moon is at its perigee, this closest point to us, this is the actual cone of its shadow being cast if the sun is on the right there. And you can see that that shadow actually extends beyond the Earth, so that if it hits the Earth, it paints a little dot there. Sometimes the moon, everything lines up, the moon is at apogee, its farthest point away, and it falls short of actually hitting the Earth. So let's explore that just a little bit. When that happens, when the moon is at apogee, even if it goes directly across the sun, it doesn't cover the sun completely. It is what is called an annular or ring eclipse, and that is what many of us saw last May when the moon passed directly in front of the sun. Here in our case, the moon is closer to perigee, and now it is going to cover the sun completely. It's an interesting fact that the moon is only 1/400th the diameter of the sun, but it happens to be 1/400th as close as the sun. Let me turn that around. The sun is 400 times the moon's diameter, but it's 400 times farther away. And so that coincidence allows us to have these total solar eclipses. And we'll get into the wheres and why-fors, but this is what happens from space when the moon casts its shadow on the Earth. Now there's a very dark inner area, that's that umbra, and around it, the moon, anyone in here would see the sun partially covered by the moon in what's called a partial eclipse of the sun. And this was taken by the cosmonauts aboard the Mir spacecraft in 1999. This was an eclipse that passed over Europe and Central Asia, West and Central Asia, and I know some of you got a chance to see that. The type is not going to come out very well, but the point of showing you this is that there is a rhyme and reason to all of this lining up stuff. And every 18 years, 11 days, and 8 hours, the moon and sun and Earth all line up in the same place again. So this cycle, which is called a Saros cycle, means that eclipses reoccur almost exactly on the same latitude and shape of the path on Earth. These blue lines, you have to be inside this line in order to see total eclipses. And you can see here that there's a kind of pattern going on where they are 18 years apart. This is, I believe, 2009, which many of us got to see. 18 years later, 2027 and 2045. The important thing is this 8 hours, because in 8 hours the Earth rotates about 1/3 of the way around, and so these tracks, although they're very similar in shape, end up being 120 degrees of longitude. I'm not going to spend a lot of time with this, but these Saros cycles, as they're called, involve hundreds of eclipses, and there is a progression within each Saros cycle, but there are many Saros cycles happening all at once. This eclipse is in Saros cycle 133, which is not shown there. So here we are down here. This is the eclipse that we are going to be experiencing. You can see the beginning of it there, and it comes down here, and it ends just off the coast of South America. The only place on land that will be seeing this eclipse is northwestern Australia over there. There's one more here I'm calling your attention to, which is the eclipse of 2017, and that is when those of us who live in the US will have the front row seat for a coast-to-coast eclipse. Those are all total eclipses, and this is a map of annular eclipses, and you can see across the western coast of the US there's an annular eclipse from last May. Those annular eclipses also belong in Saros cycles, and so that pattern repeats. All right, on to the big event for tomorrow. And this is the path. You have to be inside that line, that double railroad track looking line there to see the eclipse, which is why we've gone to all this trouble to be here. The blue lines on either side represent places where you'll see partial eclipses in 20% increments. So the first blue line, you'll see 80% of the sun covered, and then 60, 40, 20, and the limit down here in Antarctica is 0 also up here. So for example, in Suva, where we were not so long ago, they're going to see about half of the sun covered in a partial eclipse. And again, you can see that the only place that makes landfall is there in northeastern Australia, and where tens of thousands of amateur astronomers, both from Australia and around the world, have gathered to see that eclipse. Now, these eclipses occur because the moon is moving into position along its orbit. The moon doesn't move all that fast, and so eclipses of the sun are fairly leisurely events. In this case, the beginning will be at about, I'll give you the numbers in just a minute, the beginning of the partial phases where the moon first starts to nibble its way onto the sun, or the silhouette of the moon, I should say, will be at about 9, 10 in the morning. And it will take it more than an hour to work its way through all these partial phases until we get to the main event here, which is when the moon completely covers the sun. We experience totality. We are literally standing in the moon's shadow, or at least floating in the moon's shadow. And the amazing atmosphere of the sun, called the corona, comes into view. And then, after that 3.5 minutes of heart-thumping excitement, we return to the partial phases, which will again take another hour and 10 minutes. And the very last vestige of the moon will leave the sun at about 11:41 tomorrow morning. That's local ship's time. So let's talk a little bit about what to do during the eclipse. Many of you have seen eclipses before. So this will be old news for a lot of you, but there are a number of things you can do after first contact. After the eclipse begins, you're sort of doing this waiting game. You can watch the changes in the light around you as more and more of the sun gets covered. You can make pinhole images of the sun through your fingers, and let me see if I can explain this for those who've never done it before. If you cross your fingers like this at right angles so that there are little tiny holes left in between them, and let the sun stream through that, you can do that right now, and what you will get is little spots on the surface of the ground or wall or whatever that are little round dots. Those are actually tiny images of the sun. As more and more of the sun is covered and you do that, those little round images become little crescents. And so that's your own little portable eclipse projector that you can carry with you. Some people I know have gone to some length to create, you can punch holes in a piece of cardboard, your name, or a heart, or the celebrity logo, you know, anything you want, and those will be projected as well. Something I don't see done very often, but is easy enough to do, is to take a mirror, like a makeup mirror or a small compact mirror, and blacken it out, as you see down there at the bottom, and leave just a small hole, maybe 1/4 of an inch across. And be careful when you do this, but if you let the sun shine on that mirror and then project it onto a wall, again, you will get a crescent or whatever the shape happens to be. Now, as you're using your solar glasses to watch the progression of the eclipse, I'm actually going to open these, you'll see that the sun is being gradually gobbled up by the moon. If you're equipped with a pair of binoculars and you want to see this, do not put these on and then hold the binoculars up to that unless the binoculars have filters, solar filters on them. In that case, you don't need these. Do not hold these up and hold binoculars, because what will happen, those binoculars are like little telescopes. They will burn nice holes in this black plastic, and then will continue directly onto your eyes. And I'm sorry, I wouldn't want to have you injure yourself because you're using that improperly. But if you have a telescope that's filtered, or binoculars that are filtered, or even a camera with a filter that you can, with a telephoto lens, this picture was taken this morning by a spacecraft, and it shows that unlike a week ago when we started this voyage, there are quite a few sunspots in play right now. And so you can watch the moon kind of gradually mow down these sunspots as time progresses. This particular image is with the sun at the north, and so you need to kind of rotate it around. The moon will first, let's see if I can do this mentally. I think the moon is going to be starting, well, I better not do it. But in any case. So these are some images of the fun you can have with this pinhole projection technique. Trees are really great for this thing, so if anyone can lead me to the arboretum here on board, we'll be able to try that. Otherwise, anything that makes these little pinholes will do. There's some, just a couple of photos showing you how these crescents look. They're really very dramatic and a lot of fun. You can do, there's somebody making a face with a couple of ears sticking up. The other thing that happens is that, as you can see it there at the upper right, as the sun is gradually gobbled away, the reason that shadows are ordinarily every day kind of soft looking is that the sun is not a point source like a single LED. It's actually got a shape to it and it casts a soft shadow. But as we near second contact and there's less of it left, the shadows that it casts become more and more sharp. And you'll be able to see that. You can even see the individual hairs on your head, for example, as it casts a shadow near them. So as second contact, that is the beginning of totality, approaches, these are some of the things you want to look for. We'll move through these a little bit. Shadow bands, the approaching shadow, a phenomenon called Bailey's beads, the diamond ring, animals and other kinds of people, light changes, especially around the horizon, the change in winds, temperatures, clouds, and bright planets that might come out in the sky. You know, there are a lot of these effects that you don't need a camera, you don't need special equipment to really see. Shadow bands I'll talk about just a little bit. They're caused by density variations in the atmosphere. They're very similar to the ripples that occur on the bottom of the swimming pool. They're also very elusive. They don't always appear, and you might or might not see them. They'll have a kind of undulating duskiness on the deck of the ship, or if you might want to think about, if there's enough room, maybe bring a towel out from your staterooms to put it down to check them out. Again, this is an atmospheric phenomenon, so it's very much like the ripples that you see in the bottom of the swimming pool, except that it's the atmosphere that's doing the distortion. Here's a shadow band seen during an eclipse in the 1800s. So, all right. So as the second contact is approaching, imagine the moon's shadow as a cylinder of darkness, about 100 miles wide, that has touched down on the Earth's surface. It hits Australia first. They're going to see the eclipse near dawn, and it's rushing across the Earth at roughly 1,500 to 2,000 miles an hour. And as it approaches us, that cylinder of darkness, you will see it, as you see here, in the sky. This will be coming at us from the north. The sky will look dark. There might not be a cloud in the sky, but the sky will take on that dark character, much like you see with an approaching thunderstorm. As the last little bit of sunlight is extinguished, we can see something called Bailey's beads, which are down there in the corner after Francis Bailey, who discovered them and was first to record them. They get much more dramatic if you are using magnification, but you'll still be able to see a couple of them, most likely just with your own eyes, and of course with your solar filters. And then there's a phenomenon called the diamond ring, so called because when that last little bit of sun is about to be extinguished by the moon, it's a bright beacon of light, and by then so little of the sun remains, the sky has already darkened quite a bit, that the corona, the sun's atmosphere, begins to show, and you get this beautiful effect. This is the kind of thing that you'll be able to see by eye. Don't worry if you don't have binoculars or a telescope or a telephoto lens on your camera. We see it twice. We see it one at the beginning, right at second contact, and then again, right at third contact as totality is ending. Okay, during totality, we are literally going to be in that cylinder of the moon's shadow, but yet all around the horizon outside the cylinder with a radius of about 50 miles, it will be broad daylight still. And so do take time to look all around the horizon. You can see here's a 360 fisheye view of the amazing view that you will see there. There are many lighting changes that will take place, and I'm not going to propose to try to explain all of them to you, but they are really amazing, and something that if you have cameras, even if all you've got is like a cell phone camera, you can record a lot of these. And of course, by now you've probably heard, but I'll repeat, make sure that you've disabled the flash, turned off the flash on your cell phone cameras, on your smartphones, on any kind of camera that you have. If you are unable to do that or don't know how or worried that somehow you fumbled, please stop by the Travel Quest desk tomorrow morning. We have a roll of really nice black tape, and we'll be happy to cover it for you. Because the last thing you want to do, this is an individual kind of experience, these total eclipses. It's different for everyone, and you want to do your best to leave it that way and not really disturb those around you. Okay, at totality, that is right after second contact, you want to shout and scream a lot? That's okay. Everyone, it will be a great party, I promise. You might want to glimpse the chromosphere. We'll talk about that in a second. See the corona, look for prominences, look for that horizon twilight I just mentioned, stars and planets quickly. And I'm not sure we're going to get to the moon, but frantic photography. But mostly you want to sit back and enjoy the spectacle. Okay, right after that diamond ring, or just before the diamond ring at third contact, you want to pay particular attention. This is for those of you with some kind of telephoto lens or binoculars. For this crimson rim around the sun, it could be on both sides, which is the chromosphere, the lowest layer in the sun's atmosphere, which is giving off a distinct red color from the hydrogen gas there. The chromosphere is just really a couple of thousand miles thick, and it's normally masked by the brightness of the sun itself. We get to see the chromosphere during total eclipses. I'm going to skip that for a second. Now, also along the edge might be prominences. These are eruptions of gas and magnetic fields off the surface of the sun. They're not solar flares, though there is some linkage between them. They are literally eruptions that are roughly the size of the Earth or larger, and they can be very, very dramatic. They will also look pink. This will be great for those of you with binoculars. Okay, let's carry on. Here are a couple of prominences. You can see them there, and they are very, very pretty. We won't worry about this. I'm going to just show. Has anybody brought a hydrogen alpha telescope with you? All right, I see 1, 2, maybe. All right, great. Well, you're in for a good view. All right, the corona, really, which is what we're all here, what we all paid to come and see. The corona is the atmosphere of the sun. It's superheated gas. It's about 2 million degrees, and it is a remarkable phenomenon. That is, it is self-luminous. That is, a part of the corona is giving off its own light. Part of it is giving off light reflecting from the sun itself. In any case, it's about 1/1,000,000th the brightness of the sun, and we cannot see it except at a total solar eclipse. And it can take many forms depending on the time that we are in during the solar cycle. Now, the corona that I've shown here has a couple of things I want to point out. First of all, you notice this brushiness, which might remind you of your school days when you did experiments with magnetic fields and iron filings. This is very much what's going on. The sun is a highly magnetized object, and its magnetic fields extend well beyond the disk of the sun itself. And because this gas is so hot in the corona, it is ionized. It's reduced to ions and electrons, which are compelled to follow these magnetic fields. And so you're looking, it's the gas acting as a tracer for the magnetic fields. Very dramatic. The other thing I want you to note is that in this particular case, it doesn't look symmetric all around. It's not just a big blob. When we are at solar minimum, which was the case a few years ago, this is the kind of corona you would see with definite a preference of length along the solar equator and not so much at the poles of the sun. But we are now very near solar maximum. So our expectation is that the overall shape of the corona should be pretty spherical all the way around. Now, within the last few years, scientists have gotten very good at giving us a kind of heads up of what the corona will look like. So for those of you who want to be surprised, this is a spoiler alert. Put your glasses on right now so that you can't see the screen, and plug your ears. This is a company in Colorado, I think, that does predictions of the sun's magnetic field at the time of the eclipse. And because of that, they are able to give an indication of what the corona might look like. Now, this is with solar north up. We happen to be in the southern hemisphere, so that is not going to be the way we see it. So through the magic of Photoshop, I've turned it around. So this will be roughly the orientation that we might expect to see the sun at the time of totality. And just not for nothing, but in 20 hours we will have seen totality. So this is just a prediction of what we might see. So it's generally symmetric all around, but these sort of arcs, pointed arcs, are called helmets. Keep an eye out for those as you watch the totality. The other thing to look for, both just before totality and during it, is the appearance of a few bright stars and planets. This is the direction of the sun toward the horizon. At totality, it will be about 52 degrees above the horizon. That's a little bit more than directly halfway up, so a little bit more than halfway up. And to the upper left of the sun, you might look and should very obviously see the bright planet Venus. About halfway in between Venus and the eclipsed sun, you might look for Saturn. And over here, about the same distance as Venus, you might look for the bright star Alpha Centauri. There are others that might appear. Mercury's in that mix, and a couple of other bright stars. But honestly, especially if you're just doing this for the first time, I wouldn't waste an awful lot of time looking for these things. Those are the sorts of things you can do. The back of this sheet gives you some general tips for photography. I know some of the people in our group here have great expectations for recording fantastic both still photos and video, and I'm with you 100%. I hope that that will happen. I want to mention that Professor Mike Reynolds here is our photography expert, so if you haven't found him yet, please check up with him if you have questions about doing photography. Just as a general rule, if you have cell phone, smartphone cameras, or even point-and-shoot cameras, you're not going to be able to get a lot of telephoto zoom in on the sun. So as a general rule, I recommend that you concentrate on the big picture view all around, and of course cover those flashes. Did I mention that? Cover those flashes. For those of you with better equipment, I would say set the ISO, that is the speed of your detector, to 400. That's a good all-around number that will keep it from getting too grainy. And as you try to record totality, the watchword is bracket. Bracket, bracket, bracket. Pick an F ratio that you're comfortable with, and to the extent that you can with manual controls, run through exposures all the way from, say, 1,000th of a second to a quarter of a second eighth of a second, depending on how still you feel you can keep the camera as you're holding it or leaning against the rail. But by all means, don't forget to stop and look around. Eclipses can be very fleeting if you spend the whole time looking into your viewfinder. So again, this is what if you do a combination of images, short exposures for the inner corona and longer exposures for the outer corona in Photoshop or other kinds of programs, you can combine them to get some really dramatic images. This is just one example of that. So again, do not spend the whole time glued to the camera. You know, take a break, look around. Mike, I think your rule of thumb was for every 30 seconds you should take 7 or 8 seconds every half minute or so to just kind of, you know, smell the roses and see what's going on. Make sure you leave time for the diamond ring at the end. In fact, a great friend of some of ours, who, especially in the Bay Area, Norm Sperling, once said that no matter how long Totality is, it only seems like it lasts 8 seconds and then it's over. And that's a really important thing to keep in mind. 3.5 minutes sounds like a long time, but trust me, it goes by quickly. And it goes by especially quickly if you're fumbling in the dark trying to get your camera to work. So I will guarantee you that somebody will have a nice picture of this eclipse in Totality and a whole sequence that you can download off the internet and put in your little, you know, your slideshows for friends. Just make sure you enjoy this eclipse for the magnificence that it represents. Here are people who are actually on a ship. This is Bob Stevens, so I'm not sure if this was 2009 or not, but it can be very dramatic. The sky goes dark. That's another thing I want to mention. It will get very dark on board during Totality. So this is all. Likewise, don't worry about fumbling with your camera settings, and do not move around because you're going to not be able to see very well. There's going to be a lot of people up on deck, so just find a spot and be comfortable with that and enjoy the show. Okay, so we've talked a lot about the viewing glasses and be very cautious. This is a sort of telling cartoon here. You know, your eyes do have a natural kind of blink reflex that if you were to suddenly see the sun in all its intensity, your eyes would. What I'm worried about is a situation where you're looking at the sun and you're doing something that I've told you not to do, like trying to use your binoculars. It is just not worth it, not worth the risk. For those of you who've never seen an eclipse before, you will want to see others, and there will be other times. And so just be very, very careful. Here's another one. Different ways to look at the eclipse. There have been times in the past where whole countries have been told by their government to stay indoors during a total solar eclipse. And of course, we don't want that to happen. You do want to keep those filters on your head and on your cameras during the partial phases, but please, during Totality, take them off. During Totality, it is completely safe to look at the eclipse sun. It is completely safe to use binoculars, a telescope, your telephoto lenses during Totality. One of the things the captain didn't mention is that I will be on the bridge throughout the eclipse, and I will be making those announcements. So if you hear boo, boo, and then my voice will come over and tell you, just guide you through the process, when you should be using your filters, when the time is to take your filters off. And I have a great selection of rock music that I plan to play during Totality. Not. Okay, be ready when the eclipse ends, because it will be a fairly dramatic conclusion. As quickly as it got dark, it will start to get light. And let's go. This is a whole series. It's best not to stare at me during an eclipse. That's good. All right. And so a little etiquette. Again, use your flash only during the partial phases. For your video cameras, you know, as you're talking, you're going to be hooping and hollering too, but I can tell you, you'll get a much better result if you can control yourself and just let the other people around you capture the crowd noise. If you're shouting at the top of your lungs, that's all you're going to remember. It will ruin an otherwise perfectly good video. Ask her to marry you after the eclipse, or she will miss it. And and you'll be reminded of that for 3 more sorrows. Okay. So again, here's our path. We are, I'm sorry, I don't know how that got in there. That was a mistake, sorry. That was another eclipse. It looked like 2004, was it? In any case, here are the times that everyone wants to know about. Now, as the captain and Justin mentioned, we have been working very closely to optimize our location. The weather looks good, so we don't expect to have to do too much scrambling. What we are going to be concerned about is the wind and the swells on the ship. And so we're going to adopt an orientation, assuming the clouds are not an issue, that will be the best for stability all around. And so these are the times that we're working toward right now. The first contact will be at 9:10 a.m. An hour and 10 minutes later, Totality will begin, lasting for about 3.5 minutes, and then the whole show will be over at 11:41 a.m. You don't need to copy these down now. They're posted by the Travel Quest table on the 3rd deck near guest relations. All right. So now, I'm sure you've all been worried about the weather that we're expecting, and we are totally prepared here. I was hoping to download a weather prognostication as I was sitting here, so I could say, I got this off the internet just 30 minutes ago. These days, I'm lucky to get something off the internet 30 hours ago. And so this morning, I went through and I downloaded a chart. This is the brighter the color here, the more clouds we're going to have. Here's our star. Oh, wait. That was the prediction for a week ago. Here's the prediction for tomorrow. Here's the position of our ship. And light pink is basically cloud-free skies. This little pink here is no more than about 10% chance of cloud. Some of you know that Travel Quest has meteorologist Jay Anderson working with us. Jay and I have been in contact. He said basically the prediction is for no clouds at all, and although that might be a little bit on the optimistic side, we are definitely in the right place. And for those of you who might have friends in Cairns or in Australia, yeah, how about an applause for Jay? He did it himself. For those of you who might be wondering about Australia, it's a little dicier there. They have a lot of cloud, especially north of Cairns, and so some of our friends who are there might not get to see Totality, but we're hopeful for everybody, right? Everyone deserves a chance to see Totality, and we wish them all the very best of luck and weather. So Paul Gauguin will be fine. Paul Gauguin will be fine, and so here, this little star in the center here represents our position at the time of Totality. There is a weather front that will have passed by from west to east, roughly, leaving us in the clear zone behind it. There's a little bit of concern for some clouds building up off. This is New Zealand down here if you can't make it out. But I think we're going to be very, very fine. And so I think that with now only 20 or so hours to go, I hope you will be as excited as I am, and that we have a great, exciting day planned for everyone on board. But for those who might have questions, I've left plenty of time for questions. We're going to take those all after the conclusion here. But one question I know a lot of people have had is 2 questions. First of all, the ship does not have any lights on sensors, so they actually have to be turned on and off. We have asked multiple times, there should be no lights coming on during the middle of Totality, which is one good thing. The second thing is that, yes, everybody all the passengers and all the crew will have glasses, and they've been told that, did I mention that you should not use your flash during Totality? And they will be able to enjoy it as well. In fact, we've worked with the hotel manager, the restaurant manager, everyone, to try to get as many of their staffs up onto deck with us to share this wonderful, exciting event. And so with that, ladies and gentlemen, let's have a boolah for the Eclipse tomorrow. Boolah! Thank you very much.
Thank you, Kelly. Well, yeah, this is going to be great. We will have some Q&A in a second. I just want to say that at 7 o'clock in the morning tomorrow, Kelly and I will be going back on the bridge, and Kelly will be giving an address to everybody at 7:30 just as an update on our location and where the best place might be to be, if you haven't already got up there. Anyway, so I'm looking forward to tomorrow. I'm nervous and excited. This is going to be number 7 for me, so I'm hoping to see that with all of you. So I'll leave you now.
All right, some questions. Go ahead here in the middle.
Yeah, about Venus. My experience has been that
Right. His point is that you don't need to wait for a second contact to see Venus. Even, some of you, I suspect, have seen Venus during the daytime even. It doesn't take much dimming of the sky's light for it to pop out. He says you could start looking for it 10 or 15 minutes before second contact, especially because you know where to look. One thing I should have mentioned but didn't. We don't know what orientation the ship is going to be during totality. So if you ask me, I'll say we don't know what orientation the ship is going to be during totality. But if we are following along the center line, which is very possible, the sun at totality will be about 40 degrees left, that is port of the bow of the ship, and 52 degrees up. So port side viewing might be preferential at that time. But it's high enough in the sky with an altitude of 52 degrees that pretty much anywhere there is clear deck, you will have a nice view. Okay, other questions here in the front.
I saw pictures that show we're going to be able to see Mercury. Can you go back and put up that thing with Venus?
Sure, no problem. No problem. So Mercury should be right about here.
So people ought to look for that.
Well, I think it's going to be a challenge to see Mercury. It's on the far side of the sun from us. It's relatively faint. With binoculars, yes, with binoculars, absolutely. Okay, good point. Thank you. Yes?
Some of the literature has the second contact at 9:20, some of it has 10:20. Are we resetting the ship's clocks tonight?
So it's a good question. Some of the things you've seen, and in particular, the source book produced by Travel Quest has 9:20. You'll also notice down at the bottom it says we don't know what the time zone is going to be, where the ship is going to be. So between the time that was printed and now, we learned that Fiji actually does go on summertime, and that there was no confusion. And so the numbers that I gave and the numbers that are posted at the Travel Quest table are the right ones. If you remember no other number from what I told you, 10:20 is within, depending on where exactly we are, plus or minus a few seconds, is when totality, 10:20:04 is when totality is going to begin. So it is an hour later than what's in the source book. We're actually pretty close to the location that's in the source book, but the times that are there are off by a few seconds. And again, I want to emphasize, depending on what's going on with the wind and the waves, and there might be cloud, we are prepared to scramble, and those times are going to change. However, I have with me, through the miracle of computers, and this is a shout out to Roger Sinnott of the staff of Sky and Telescope, who for 20 years has provided me with a basic program that I run on my computer that tells me instantaneously what the contact times are, no matter where I am within the path. So I'll be giving those. Way in the back there.
Yeah. Will the helipad be open?
Yes, that is the plan. And the helicopter pad, which is on the front of the ship, will be open. And Rich, the cruise director, is trying to figure out how to make that knowledge available to everybody without creating a stampede. Now let me tell you a couple things about that. First of all, it will be off limits if the deck is wet, because it doesn't have the non-skid surface that the other places do. Second of all, there is only space there for about 50 people. Third, it is accessed through the crew quarters, and so there is no handy bathrooms. There is no way to get out of the sun easily. So if you're thinking that you might want to be on the helipad, and I've been out there, it's a beautiful location, right? It's a really nice spot. understand that you're probably going to be there for the duration. There's also some high bulkheads that you have to cross through. This is a decision that Rich is making. It is available to us and to others. And so if I were a guessing person, I'd pay attention to what deck you need to be at to get to the helipad, and that doorway, say around 7:30. But we don't know for exactly when that's going to be made available. Again, Rich is going to be making, the cruise director will be making an announcement to the whole ship. Yes, in the back. There's two. Go ahead, sir.
Does Travel Quest lock down any portion of the deck for Travel Quest people?
Yeah, so the question is, have we locked down any portion of the deck for our own people? We have asked this question since the first day, and the cruise director and staff have been reluctant to give us a dedicated part of a public space for our exclusive use. What we plan to do is to find a section of the deck that is suitable for viewing, given the conditions wherever we have to be, and to have our staff. We have right now we have 13 people on board who have been assisting you in making this the best experience possible. And so we're going to find a place where you can set up your equipment and feel comfortable knowing that we will be there watching it, so you can leave, go get a drink, go to the bathroom, get inside out of the heat, whatever that might be. So with that, let me preface this question by saying you are free to go anywhere on the ship that you want to be, okay? We are not asking you in any way, shape, or form to conform to a particular area you want to be. There is a lot of deck space. They are planning to take up most of the chairs, the lounge chairs, and that might sound good because it's certainly going to increase the floor space. Understand that means you won't have a place necessarily to sit, except on the deck itself. So bear that in mind. Make it an ergonomic Eclipse in terms of your own comfort and safety. So with that as a preface, I'd like to see a show of hands, and Deborah, maybe you can kind of help me out here. How many of you would like to be in an area that is, while not exclusively for our use, at least an area where your belongings, cameras, and so forth could be watched if you need to go away? Okay, it's looking like about half of you, all right, roughly speaking. So that's good for us to know. That means that we'll just take decks, 7, 8, 9, 10, 11, and 12, and leave the rest of them. But thank you for that. Again, that's something that it may be a little bit challenging to communicate this all to you tomorrow morning. We're going to be on station, as it were, beginning at 7 o'clock. The desk will be open at 7, yes, and by then, in fact, right about that time, we're going to have our last meeting with the captain. And so if you're looking for that location, please stop by the desk if you want to keep that as Travel Quest pure as you can. It's not the sort of thing you might necessarily share at dinner. So, other questions? Sir, go ahead.
You are going to announce, what are you going to say? Take that people to take off their glasses so they don't miss barely beads. That's right.
I'm going to say take off your glasses
When?
before second contact, just before second contact, so that they can see. Yes, sir. I'm going to be on the bridge, and we've got us. Yes, and you're absolutely right. You're absolutely right. Yes, we plan to announce all the major times. I'm going to be mostly radio silent during Totality itself, except for that rock music, of course. I'll tell you when second contact is. We'll be looking ourselves for any prominences that might be available. I'll give a call when we're halfway through Totality, and I'll probably give one more call about 10 or 15 seconds before the end of Totality, at least as the clock. You'll be knowing that yourself because you'll see that the limb of the sun will gradually start to brighten. And I don't think I mentioned this during the talk, but the moon will start nibbling on the sun from the upper left and proceed diagonally across it and exit the lower right. Okay, other questions? I'm scanning up in the balcony. Don't see anybody up there. Yes, go ahead.
Are we going to be able to see shadow bands on the surface of the sea?
Wow, shadow bands on the surface of the sea. Now, Professor Mike, you've done quite a few of these shipboards. I don't think shadow bands on the surface of the sea is in play, in part because they have a spacing. They're not large. They're just really kind of footish in width, not more than that. And at that point, we're so far away from the sea, even if it were glassy, I don't think our eyes would really be able to resolve. Right. The captain has been talking about 2-meter high swells. Swell. And you need a highly reflective surface in order to see them. So I'd stick with the deck. I think that's a better bet. I think that's a great idea. Well, the construction crew will muster at 5 a.m. You know, I've said all along that I welcome your questions and concerns, and just as an indication of the kind of detail that we are thinking of that you might not have even thought of, we have had our eye on some areas on the ship that are really good viewing locations, but we're thinking about things like smoke from the smokestack. Had it not been for TravelQuest, all of the decks would have been washed at 5 a.m. tomorrow morning. They're now not. They're going to be washed tonight and dry, to the extent they can be dry, for us tomorrow morning. I encourage you to look for your own best place to be. It gets light pretty early, around about 5:15, and you'll be free to set up wherever you wish. Let me take just 2 more questions and then we'll call it a day. All right, I see 2 in a row there, the one in behind. Go ahead.
You were going to bring up about being sure with the wind to have something to put your filters in and stuff when you take them off, or they'll be in the ocean.
A real good point. So if it is windy on deck, those of you who have benefited from all those dozens of filters that we've made or that you've brought yourself, be mindful of what you're going to do with those during totality. And if it's windy, one good way is to use some tape to literally tape them to your binoculars or your cameras so that they flip down, not up. They'll flip down and out of the way, and then they're right-handy so you can pop them back up. That's a really good point. Thank you. The other question?
Is it high enough that we can be in the middle, or should we all be by the way?
The question is it high enough that we can all be in the middle? It is high enough that I think for most of the deck areas, I mean, unless you're really interested in seeing the eclipse sun eclipsed by a smokestack, and that's about 20 square feet of deck space, that pretty much every open spot of the deck, the sun will be high enough at totality to see. With that as let me just give you the caveat that first contact is supposed to be 38 degrees up. It's morning after all. It's morning progresses. So, and by the end, it's going to be in the 68. I think sticks in my mind. So. But totality itself, it's a really good angle for us. Think ergonomically for those of you who are going to be taking pictures that, do you want to be holding your binoculars up for long periods of time like this, or your camera? One tip on your cameras, most of us, with DSLRs, most of us have zoom lenses on our cameras. And so there are 2 concerns I'd warn you about. First of all, infinity, the infinity mark on your lens barrel is not necessarily infinity, so practice taking some pictures of the sun beforehand with the filter on, of course. And the second thing is that because it's a zoom lens, it's going to tend to slide back to its wide-angle position. So think about getting a piece of tape to literally taping the lens in place so that it can't turn. Oh yeah, the other thing is that turn off your automatic focus and work it manually, and I think you'll have a much more satisfactory result there. All right, one more question, and then we're going to call it a day. Yes, way up there.
Are we likely to see any unusual behavior from marine life, such as dolphins jumping out of the water?
I think you all heard the question. Yes, I don't think we're going to have any breaching dolphins or whales. I think there will be, however, some unusual animal life here on deck. And I wouldn't be surprised if some calmative liquids appear from the staff shortly after totality to ease and soothe the fretted beast. And with that, ladies and gentlemen, we're going to call it a day. We'll see you tomorrow. Let's hope for, as Deborah says, calm seas and clear skies. Thank you very much.